Okay, this is a continuation for lesson 25 with some more problems. On your sheet, we're going to skip this one. It's a little bit difficult the way it reads, and so I don't want to confuse everybody. You have other ones that are like it, though. So number 8, Alfonso working alone can do 3 jobs in G hours, and Marty working alone can do 2 jobs in H hours. How long will it take Alfonso and Marty to do 2 jobs if they work together? So the first thing we know is their individual rates. So the rate for Alfonso is 3 jobs in G hours. So it's jobs over hours. And the rate for Marty is 2 jobs in H hours. Again, this is jobs over hours. It says, how long will it take them to do 2 jobs if they work together? So if they're working together, we're going to add their rates together, times how long they work, and they want to complete 2 jobs. So we have 3 over G plus 2 over H times T equals 2. So get a common denominator here, which is GH. So we need to multiply both of those by H, so you get 3H. Both those by G, so you get 2G. Then you multiply both sides by the reciprocal, so 2GH over 3H plus 2G. And this unit is hours. So I want to make sure you saw one with abstract answers. The next one, a plane flies 600 miles in 2 hours with a tailwind. It takes the same plane 4 hours to fly the 600 miles when flying against the wind. What is the plane's speed in still air? Okay, so the first thing, this is like those boat in the river problems we had last year. So we know with a tailwind, then it's his rate plus the wind speed would be his total rate. And that plus the time with the tailwind equals the distance with the tailwind. Okay, against the wind, going to work against him, so it's going to be his rate minus the wind speed times the time going against the wind equals the distance going against the wind. So it tells us that 600 miles with the tailwind, so we have 600 here, and it says it took 2 hours, so this is a 2, so we can sub that in, and we can go ahead and multiply that out. And I would go ahead and divide everything by 2, just to simplify it. Over here, it says that it took him 4 hours against the wind, and he also went 600 miles, so it was the same trip. So we get 4R minus 4W equals 600. Again, I would divide everything by 4, and this is 150. So we know that we have this one and this one. Now I can add these two together. If I add them together, I'll get 2R. The W's are going to cancel, and I'll get 450. So R is going to be 225, and that would be miles per hour. And that's the plane's speed, is the plane's rate in still air. Okay? Okay. Let's look at the back. It says Thor's average driving speed is 7 kilometers per hour faster than Mia's. In the same length of time it takes Thor to drive 296 kilometers. Mia drives only 268 kilometers. What is Thor's average speed? So it says his speed is 7 more than Mia's speed. So it says in the same length of time, so that means the time for him is going to be the same as the time for her. It says that his distance, so Thor's distance is 296, but Mia's distance is 268. Now we know that we can say that Thor's rate times Thor's time is Thor's distance, and Mia's rate times Mia's time is Mia's distance. So, what do we have here? We have this that I can substitute in right here. And then I can, you know, they're equal, so I can do that, and got 296. Do distributed property. Now, I've got this right here, but I know what that is because it's going to be equal to whatever the distance is, and the distance is 268. So I can plug 268 right here. And then I can subtract it from both sides and solve for Mia's time. Now, that's not my answer, but it is Mia's time. I want to know what his average speed is. So I'm going to use this equation. I want to solve for this, his speed, right? I know his distance is that. I also know that their times are the same. So that means his time is 4. So if I take 4 and divide both sides by it, I'm going to get 74. And that's going to be kilometers per hour. Yeah. I just wanted to give you those extras.